Okay, so I think one of the most interesting things that we can see here is that there are parts of the pattern that change. Let's imagine this is time going on. You think of things that change as time goes on and parts that don't change. And here we've got it separated really beautifully because we can see the red dots don't change and the blue dots do change. But if you imagine all the dots were black, it might be a little bit of a puzzle to figure out which parts are changing and which parts aren't changing in this pattern or in this pattern. And in fact, if I made all the dots black, I might say that this section down here doesn't change, and this part is the staircase on top that changes. And that would actually be equivalent to what we've done. It would be a different way. You could imagine if you wanted to do this again, you could choose to put the reds at the bottom and the blues on top, and then the reds would all stay the same across the bottom. And that's actually an important part of what I do in my work, is figuring out in our mathematical models, the math that we apply to some system in biology, we want to know what's changing and what isn't changing. And in fact, just this week, I was saying, we had a problem with one of my graduate students. So she's at a very advanced level in mathematics. She's working on her PhD. She's almost done. And she's doing a system that models the immune system in the body, so how your body fights off viruses and bacteria when they attack you and make you sick. And it turns out that in some parts of the system that she's modeling, there are parts that changed and parts that didn't change, and we were able to make the model much simpler once we could identify the bits that really weren't changing, and we could reduce the model, make it smaller, and make it something that we can understand more easily. So that's what I did this week in my research.